Good evening everyone, good evening. I welcome you all again to the NEET Elite. Hoping that you guys are doing great, having the good time. Well people, you can let me know in the chat box if I'm audible and visible to everyone. You can let me know in the chat box with some thumbs ups, yeah? Let me know in the chat box with some thumbs ups if I'm audible and visible to every single guy right here. Perfect. Good evening, Shweta. Hello, Abdulaziz. Hi, Sana. Hi, Arzu. Hi, Levin. Hi, Nikita. Hi, Jahangir. Welcome, everyone. Hi, Ashwarya. Hello, Karthik. Perfect. Hi, Deepa. Hi, Aditi. Hi, Bhumika. Welcome to the session. Welcome. So, people, as you all must be knowing, in the last session of the isomerism, we talk about something called as structural isomerism, yeah? And in the last session itself, we finished the chain isomers, position isomers. We talked about something called as functional isomers as well. Yeah, perfect. And people, in the today's session, what we are going to do is we are going to start with the ring chain isomerism, followed by metamerism, and at the end we'll be talking about something called as degree of unsaturation as well. So these are the things which I'll be covering right here in the today's discussion. Okay. I'm doing great, Arbaz. I'm doing great. Hello, Ashwa. Good evening. Yes, I'll be letting you know about the schedule soon. Maybe tomorrow you'll be getting it in the community. Right? Good evening, Peter. Good evening. Good evening. Welcome back. Perfect. So, for the ones who are new to the channel, let me introduce myself. My name is Wassim Sir, and I'm your chemistry master teacher right here on this NEET Elite channel. Yeah? Perfect. And for the ones who have not liked the video yet, please do like the video, share the video with your friends, and subscribe the channel at the same time, and do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking right here on this NEET Elite channel. Yeah? Perfect. Good evening, Dinesh. Welcome. Hi, Priya. Welcome back. Perfect. So let me know in the chat box if you guys are super duper excited about the session. Let me know in the chat box with some thumbs ups. Yeah? Let me know in the chat box if you guys are super duper excited about the session. I'm doing great, Priya. I'm doing great. Hello, Mahak. Hi, Mohit. Perfect. Let me know in the chat box if you guys are super duper excited about the session so that we can start session directly without wasting a lot of our time. Yeah? Perfecto. Perfect, guys. 2022 batch, I'll be starting next week. I mean, the coming week, okay? Right? NEET 2022 batch on this channel, on this NEET Elite, I'll be starting in the coming week, right? Shweta, I'll be doing the coordination chemistry as well. Relax, do not worry. Everything will be done. Perfect. So let's get started with the today's discussion, in which we'll be starting with something called as ring chain isomerism. Okay. So first of all, what are these ring chain isomers? As per its definition is concerned, first understand the definition. I mean, read the definition, then I'll make you understand what this ring chain isomerism is all about. Yeah. What these ring chain isomers are all about. I'll be letting you know that. Correct? Understand. First of all, guys, the compounds, just a second. Perfect. Compounds having same molecular formula but possessing open chain and cyclic structures are called as ring chain isomers. Okay. Ring chain isomers, these are the ones which have got, first of all, same molecular formula, but they'll be possessing open chain as well as cyclic structures. Okay. What do we mean by that? What do we mean by that? Let's understand it properly. Okay. Let's understand it properly. Let me take few examples which are going to make your ring chain isomers clear, right? This is the first example which I've taken. By just looking at this example, your ring chain isomers are definitely going to get cleared. Understand properly. Say, guys, let's say I've got some molecule whose molecular formula is C3H6, yeah? Let's say I've got the molecule whose molecular formula is C3H6. Now, first of all, what all possible structures can I draw for this molecule? What all possible structures can I draw for this molecule whose molecular formula is C3H6? Well, people, if you look at this structure right here, over here you've got carbon, which is attached with two hydrogens as well. Over here you have got carbon attached with 2 hydrogens as well, and over here again you have got a carbon attached with 2 hydrogens as well. So first of all, this is the first possible structure for the C3H6 molecule, right? Similarly, one more structure is going to be the open chain structure. Just have a look. Again, you have got 3 carbon atoms and 6 hydrogens. 3 plus 1, 4, 4 plus 2, 6, right? So this is one more possible structure of this C3H6 over here. Now, just understand one thing. Just this one is cyclic, right? This one is cyclic and this one is linear. Both the molecules have got same molecular mass. Both the molecules have got same molecular mass, but the first one is cyclic and the second one is open chain structure, right? These are the 2 molecules which have got same molecular formula, but one is having cyclic structure, one is having open chain structure. We call these 2 molecules as ring chain isomers, as simple as that, right? So these 2 molecules, these are basically ring chain isomers over here, correct? Similarly, if I take few more examples, understand properly. I'll be taking few more examples. Have a look. I've got the molecule with the formula C4H8 first of all, yeah? I've got the molecule with the formula C4H8. First of all, I'm drawing 2 possible structures of this molecule. This is one possible structure. At every corner you have got the carbon atom. These are basically the carbon atoms. And over here, it's attached with 2 hydrogens. One more carbon is attached with 2 more hydrogens. Similarly, this carbon attached with 2 more hydrogens. This carbon attached with 2 more hydrogens, right? So over here, we have got again 4 carbon atoms and 8 hydrogens at the same time, yeah? And at the same time, if you'll have a look on it, it is ring-like, it's cyclic, yeah? It's one more possible structure is going to be this one. This is the open chain structure. This is the open chain structure. If you will compare these 2 structures, this one is ring shaped and this one is open chain. So first of all, these 2 molecules, they have got same molecular formula, but one is cyclic, one is open chain. So I'll be calling these 2 again as ring chain isomers, as simple as that, yeah? Similarly, if you take one more example, which I've taken over here, the molecular formula is C4H6, right? And this is the open chain structure, correct? And this is the cyclic structure. See people, if you compare both these molecules over here, both these molecules have got same molecular formula C4H6, correct? So what is the difference? This is open chain structure, this is ring shaped structure, this is cyclic structure, right? And whenever I'll be having 2 molecules which will be having same molecular formula, but one will be cyclic, ring shaped, another one will be open chain, I'll be calling these isomers right here as the ring chain isomers. Let me know in the chat box if you got the concept of what these ring chain isomers are all about. Just let me know about it in the chat box. Let me know in the chat box if you got the simple concept of what are ring chain isomers. So I'm repeating the same thing. Ring chain isomers are the ones which have got same molecular formula, but one of them is going to be the cyclic and the other one is going to be simple linear chain one, yeah? Okay. Let me know in the chat box. Let me know in the chat box. Perfect. Let's move on. And let's get started with something called as metamerism. Okay, this is one more type of isomerism which we are going to talk about right here. Okay, so people, till now what all things we have talked about, if you remember, we started with something called as chain isomers, then we talked about position isomers, then we talked about something called as functional isomers, and then we talked about something called as ring chain isomers. Okay, now let's talk about something called as metamers, right? Well, let's read the definition first, then I'll make you understand what these metamers are all about, yeah? Okay, see guys, have a look as per its definition. Yeah, so first of all, metamers, these are the compounds. Definitely they'll be having same molecular formula. They'll be having same functional groups as well. First of all, metamers, these are the compounds which have got first same molecular formula, same functional groups, but what is the difference? The difference is in the arrangement of alkyl groups around a polyvalent atom. Around a polyvalent atom or a group, okay? What do we mean by that? How can we understand this? Just wait for it, you'll get the clear-cut idea in like 2-3 minutes, okay? First, remember the definition. Metamers, these are the compounds which have got same molecular formula, same functional groups, but the arrangement of alkyl groups around the polyvalent atom is going to be different. Okay, around the polyvalent atom or polyvalent group, it's going to be different, right? Same molecular formula, same functional groups, okay, and at the same time, they differ in just one thing, that is the arrangement of alkyl groups around the polyvalent atom or the group, right? So first of all, you should know what are the examples of monovalent groups and polyvalent groups. Then only you can understand this metamerism in detail, okay? So let me give you first of all few examples of the monovalent groups and the polyvalent groups. See guys, so first of all, talking about the examples of the monovalent groups, see all the halides, it can be like this. See, all the halides which include fluorine, which includes chlorine, which includes bromine, okay, these are the examples of monovalent groups. Similarly, hydrogen, which can be attached with the carbon chain through this single bond. OH group, which can be attached through the carbon chain with this single bond, right? CHO, which can be attached through this position with the carbon chain. COH, which can be attached with the carbon chain through this position. CN through this position. NC through this position. All these groups, these are the examples of monovalent groups, right? They'll be getting attached with the carbon chain through one way, okay? And remember, your monovalent groups, they do not show the metamerism. They do not show the metamerism. What is the reason for that? You'll get the clear-cut idea in some time. First of all, point number one, which I want you guys to take a note of. All these monovalent groups, they are not going to show metamerism at all, correct? But your polyvalent groups, they are going to show the metamerism, right? So first of all, what are the examples of these polyvalent groups over here? Have a look, guys. These are the clear-cut examples of the polyvalent groups over here. See, guys, understand. If you take the first example, oxygen can get attached with the carbon chain through these two positions, right? So it's a bivalent basically group. It's a bivalent group. Similarly, this is a trivalent group, right? Similarly, this is again your divalent group. This is again your trivalent group. This is again the divalent group. This is again the trivalent group. This is again the divalent group. These are all the examples of the polyvalent groups in general, I must say, right? These are all the examples of the polyvalent groups in general. And all the polyvalent groups, they are going to show the metamerism. Whereas your monovalent groups, they are not going to show metamerism at all, right? So people, what I told you, what is the definition of what are the definition of metamers? Metamers are basically the compounds which have got same molecular formula, right? Same functional groups, okay? But the arrangement of the alkyl groups around the polyvalent atom or the group is going to be different, right? How can we understand all this in detail? Have a look, guys. Let me take the clear-cut examples so that you get the idea about the metamerism. This is something which I told you. Monovalent groups, they never show metamerism, but your polyvalent groups, they can show something called as metamerism over here. Yeah? Let's move on. Let's take the example, and by means of these examples, you can get the concept of metamers over here. See, let's check the first example. Let's check the first example. I've taken two molecules right here. This is molecule number 1. This is molecule number 2. First of all, I need to check, do these molecules have same molecular formula? Yes, these two molecules, they have same molecular formula. You can check it out as well, right? See, you have got 1, 2, 3, 4. You have got 4 carbon atoms, right? You have got 4 carbon atoms. How many hydrogens do we have? 3, 2, 5, 7, 7, 3, 10. C4, this is going to be H10, and over here we have got oxygen as well. Similarly, if you talk about the molecular formula of this compound over here, it's again going to be C4H10O. So first of all, these two molecules, they have got same molecular formula, number 1, right? Number 2, understand. Number 2, understand. Identify the polyvalent group in the two molecules. This is the polyvalent group. This is the polyvalent group over here, right? Now, after identifying the polyvalent group, now what you are going to check over here is, you are going to check the arrangement of alkyl groups around the polyvalent groups, around the polyvalent atom or group, right? See guys, understand. If you talk about the first example, what is the surrounding of this polyvalent group? On one side you have got ethyl group, on another side you have got ethyl group, right? So on one side you have got ethyl group, on another side you have got ethyl group, right? Now people, check the surrounding of this polyvalent group over here. On one side you have got the methyl group, on another side you have got the propyl group, right? So just check it out. Is the surrounding of this polyvalent group same on both the ends? The surrounding is different. The surrounding of the polyvalent group is different, right? So I can clearly say these are going to be the metamers of each other. Yeah. So first of all, these two molecules, they have got same molecular formula, they have got same functional group, but at the same time, the arrangement of alkyl groups around the polyvalent group in both the molecules, it's different. So the first two molecules, these are basically the metamers of each other. Yeah, I'm sure it's clear to you. Similarly, just check the second one so that you get a clear-cut idea of this. See, first of all, both the ones, they have got same molecular formula. This is something which I'm telling you from here only. Yeah. Now, identify the polyvalent group. This is the polyvalent group. This is the polyvalent group right here in this molecule. Okay. Right here, you have got the ethyl group attached with the polyvalent group. On this side, again, you have got ethyl group attached with this polyvalent group. Okay. But in this one, you have got propyl on one side of it. Similarly, methyl on one side of it. Right. Is the arrangement of alkyl groups same or different in these molecules around the polyvalent group? The arrangement of alkyl groups in these two molecules around the polyvalent atom, around the polyvalent group is different. So again, these two are going to be metamers of each other, right? Yes. Similarly, if I compare the last one, I need to check, are these two molecules metamers or not? Let's check it. Let's check it. First of all, I'll be checking the molecular formula. And something I'm telling you, molecular formula of both these molecules, it's same, right? It's same. This is something which I'm telling you from here only, yeah? Now identify the polyvalent group. This is the polyvalent group over here. This is the polyvalent group over here in this molecule as well, right? Check the alkyl groups which are attached with this polyvalent group, right? This is the methyl group attached with this polyvalent, and this is the propyl group attached with this polyvalent. Similarly, this is ethyl group. This is again the ethyl group. Now people, if you compare these two molecules, right, the alkyl groups which are attached with these polyvalent groups in both the molecules, are these same or different? These are definitely different, right? Okay, and we know if the alkyl groups attached with the polyvalent groups will be different in both the molecules, I'll be simply calling them as the metamers. So again, these two are metamers of each other, yeah? Let me know in the chat box if you got the concept of what these metamers are. Yes, Yasser, exactly. Right. Let me know in the chat box if it is clear to everyone. Let me know in the chat box. Let me know in the chat box if it is clear to everyone so that I can move on. Yeah? Wonderful. Sneha, stereochemistry we will be starting in the next session. Okay? Perfect. Wonderful. Let's move on then. Let's move on. Let's take a few more examples. Now you guys are going to let me know, are these two molecules metamers of each other or not? What do you think? What do you think? What do you think? First of all, identify the polyvalent group. This is oxygen right here. This is oxygen. I've identified the polyvalent groups, right? First of all, these two molecules, they have got same molecular formula, number one. Yeah? They have got same molecular formula. Number two, functional group is same. Yeah? Functional group, matlab polyvalent group is same, correct? Now check the surrounding of this polyvalent group. On one side, you have got methyl group, right? That means this oxygen atom on one side is attached with the methyl group. And if you check this one, on one side of this oxygen, I mean this polyvalent group on one side is attached with the same methyl group, right? So right here, one of the alkyl groups attached with the polyvalent group, it is same, correct? So are these going to be metamers of each other? Are these going to be metamers of each other? These are not going to be the metamers of each other, right? Because on one side of the polyvalent group, you have got same methyl group attached in both the molecules. So these cannot be the metamers of each other, correct? Yes. Perfecto. Right? Now people, I want you guys to compare these two molecules. This is one molecule, this is one more molecule. People, if you remember in the last session, I have told you one important thing about functional isomerism. I hope you remember. This is 2 degree amine over here. This is 2 degree amine, yeah? And this is 3 degree amine. 2 degree amines and 3 degree amines. First of all, their molecular formula is same, right? But this is 2 degree amine, this is 3 degree amine. So these are going to be directly the functional isomers, right? In the last session, I've told you, correct? So these are clearly going to be the functional isomers. Yeah? Correct? Correct. What is happening? Just give me a second, guys. Till then, you can let me know in the chat box if everything is clear. Yeah? Correct? Perfect, guys. Perfect. Let's move on. Let's talk about a few more interesting things. Wait, guys, let me mute the audio right here. Just a second. Can you let me know in the chat box if I'm audible now? Can you let me know in the chat box if I'm audible now? Yeah? Just let me know in the chat box if I'm audible. Yes, Yasir, surely. All right, perfect, guys. Okay, so let's talk about these. Let's talk about these molecules right here. Identify which one shows metamerism. Okay, so first of all, let's talk about the first example in which I've got these two molecules. Molecule number 1, molecule number 2, correct? Now, people, first one thing which I'm telling you from my side only, both the ones, they have got same molecular formula, right? No need to check the molecular formula right now. I'm telling you they have got same molecular formula, yeah? After checking the molecular formula, identify the polyvalent group. This is the polyvalent group right here. Similarly, in this one, this is the polyvalent group, right? Now check the surrounding of the polyvalent group. See, in the first compound, oxygen of the polyvalent group is attached with this ring over here. But in the second one, oxygen is not attached with the ring, oxygen is attached with this CH2CH3, correct? Yes. So is the arrangement of both these molecules around the polyvalent group same or different? Right? I'll say arrangement of alkyl groups around the polyvalent group right here, it's different. So both the ones are going to be metamers of each other. Yeah? See, I just checked this oxygen over here, it's linked with this cyclic one over here. Similarly, this oxygen, it's not linked with the cyclic one over here, it's linked with simple ethyl group. This carbon, it's attached with this cyclic one. This carbon, it's not attached with the cyclic one, right? So these are definitely going to be metamers of each other, right? Simply you need to check the arrangement of alkyl groups surrounding your polyvalent group, right? If the arrangement of alkyl groups surrounding the polyvalent groups will be different, then only they are going to be metamers of each other, correct? Omkar, this is not for the students moving from 10 to 11th, okay? That session I take in the morning 10:30. Perfect. Let's move on. Let's check these two. First of all, their molecular formula is same, which I'm telling you from here only, yeah? Now, what you're going to identify is, you're going to identify the polyvalent group. This is the polyvalent group right here. Again, this is going to be the polyvalent group. Now, check the surrounding of polyvalent group. In the first molecule, the oxygen of the polyvalent group, it's attached with this double bonded carbon, right? But over here, oxygen of this carbon atom, oxygen of this polyvalent group, it's not attached with the double bonded carbon, right? Yes, correct. In the first one, carbon of the polyvalent group, it's attached with CH3. In the second one, carbon of the polyvalent group, it's attached with the double bonded carbon. So if I ask you, is the surrounding, are the alkyl groups surrounding these polyvalent groups same or different? Is the arrangement of the alkyl groups around these polyvalent groups same or different? Arrangement is different, so definitely these two are going to be again the metamers of each other, yeah? Right? Right, let me know in the chat box, fast. Exactly, guys, exactly. Wonderful. Exactly, these are going to be metamers of each other. So how did we check it basically? I checked the alkyl groups which are surrounding this polyvalent group right here. Similarly, I checked the arrangement of the alkyl groups surrounding this polyvalent group right here, yeah? And the arrangement of the alkyl groups surrounding the polyvalent group was different, so I can clearly say these are metamers of each other, yeah? Okay, moving on to a few more examples. Now you guys are going to let me know the first case among these. So first of all, are these going to be the metamers over here? Let's check it out. Let me tell you, both the ones have got same molecular formula. Both the ones right here have got same molecular formula, yeah? Now, after checking that, what do we need to identify? We need to identify the polyvalent group. This is the polyvalent group right here. This is again your polyvalent group, okay? Now, people, understand. Oxygen of the polyvalent group, it is attached with CH3. Over here, oxygen of the polyvalent group, it's attached with the benzene ring, okay? Similarly, carbon of the polyvalent group, it's attached with the benzene ring. and carbon of this polyvalent group is attached with CH3. So if I say something like this, the arrangement of the alkyl groups around the polyvalent group is different in both the two, so they are going to be metamers of each other. As simple as that. Yeah, exactly. Correct? Exactly, guys. Wonderful. What about this one? Are these two going to be metamers? Can you let me know in the chat box fast? Are these two metamers? Let me know in the chat box. These two are not metamers. These are just identical molecules, okay? These are just identical ones. It is just I'll reverse the first one. It is just I'll reverse the first one and I got the second one. Okay, so these are identical molecules. These are not isomers of each other. Yeah, got it? These are identical ones. You can check it out. This is the group. Oxygen is attached with carbon on one side. Oxygen is attached with this phenyl ring on another side. Similarly, this is the group. Oxygen is attached with CH3 on one side, phenyl group on other side. These are basically your identical molecules, right? Okay. Taking a few more examples. Let me see if you can talk about these as well or not. Okay, talking about the first example, what do I have to check? A relation between the following molecules. I need to check what kind of isomerism exists between these molecules, right? Okay, understand. First of all, I'm giving you two molecules right here. Their molecular formula is same, which I'm telling you from my side only, okay? Molecular formula of these two molecules is same, correct? Now, people, just give the numbering. Let's say this carbon number 1, 2, 3, this is 4, this is 5, this is 6, this is 7, right? Okay. Give the numbering over here as well. It's 1, this is 2, 3, 4, 5, 6, 7. People, just look at these. Just look at these properly. Look at these properly. It's 4-ethyl heptane, yeah? It's again 4-ethyl heptane, right? Okay? Right? It's 4-ethyl heptane, correct? Similarly, this is 4-ethyl heptane as well. So again, these are identical ones. Again, these are identical ones, right? Yeah? Right? Let me know in the chat box if it is clear. Again, these are identical ones, correct? Perfect, exactly. Now, what about these two? What about these two? Which kind of isomerism exists in them? See, guys, if I give the numbering of the carbon atoms in this ring over here, it's going to be, for example, 1, 2, 3, 4, 5, 6. Similarly, if I give the numbering over here, it's 1, 2, 3, 4, 5, 6. Let's get the AB number for this molecule over here. Okay, how many carbon atoms are in the ring right here? 6 carbon atoms. Okay, how many substituents are there which are directly attached with the carbon, which starts from the carbon? This is your CH3, this is CH3, and this one also starts with the carbon. So B value is 3, right? So AB value for this molecule is 63, correct? Okay, this is one substituent starting from carbon, one more substituent starting from carbon. This is one more substituent starting from carbon, 63. Similarly, if I check it over here, how many number of carbon atoms do we have in the ring? 6 carbon atoms. How many substituents are there starting from the carbon? This one, and this one. So again, it's 63. So AB number for both the ones comes out to be same. If AB value is same, are these going to be chain isomers or position isomers? I told you in the last session, if you remember, if AB value for two isomers comes out to be same, we call them as position isomers. So these are basically the position isomers of each other, yeah? Right? Exactly. Exactly, guys. Wonderful. Let's move on. Let me take a few more cases. Okay. What about the case number 3? What kind of isomers these two molecules are? Can you let me know in the chat box? I just want to see what kind of isomers these two molecules are. People, their molecular formula is same. Okay. Molecular formula is same. Now, what I'll be doing, I'll give the numbering. And this is a bicyclo compound. We start the numbering from the bridgehead. It's 1, this is 2, 3, this is 4, 5, 6, 7, 8. Okay. Similarly, this is, for example, 1, 2, 3, 4, 5, 6, 7, 8. Right? Is there any substituent attached? No. Is there any substituent attached? No. So the AB number for this is going to be 80. The AB number for this is again going to be 80. The AB number for both the isomers is same. So again, these two isomers are going to be your position isomers, right? Okay, very simple, as simple as that. Correct? What about this next one? What about the next one? First of all, let's give the numbering. Let me tell you first of all, the molecular formula of both these ones is same. Molecular formula of both these ones is same. Now let's give the numbering first. This is carbon number 1, 2, 3, 4, 5. Okay, give the numbering over here. This is 1, 2, 3, 4, 5, 6, right? Okay, so how many carbon atoms do we have right here in the parent chain? We have got 5 carbon atoms in the parent chain. How many substituents do we have starting from carbon? We have got one substituent, that is this CH3, which starts from carbon, right? So AB value for this molecule is 51. What about this one? It's simply going to be 60. There is no substituent starting with the carbon. Yeah. So is the AB number for these isomers coming out to be same or different? AB value is coming out to be different. So should I be calling these as chain isomers or position isomers? Definitely I'll be calling them as the chain isomers. As simple as that, right? Exactly. Exactly. All of you are perfectly correct. Yeah. Exactly, guys. Wonderful. Let's move on. Let's take a few more examples if we have. No. Let's talk about one more topic. That's what we call as degree of unsaturation, or you call it as double bond equivalent. Okay. Right? This is one more topic. First, let me know in the chat box, is everything clear till here? Is everything clear till here? Let me know in the chat box. Let me know in the chat box first. Yeah? Let me know in the chat box if every single thing is clear till here. Till then, I can have some water. So I'm getting some green signal from the chat box. That means I'm supposed to move on. Yeah? Perfect? All right. Wonderful, guys. Let's move on. Let's talk about something called as degree of unsaturation, which we represent by du, or we call the same thing as double bond equivalent as well, or you represent it by dBe. The choice is all yours. Yeah? Now, what kind of idea this degree of unsaturation gives us? Well, people, if you get the degree of unsaturation for a compound, for a molecule, you get the clear-cut idea of the number of pi bonds or the number of cyclic rings in the molecule, right? Okay. From this degree of unsaturation, you get the clear-cut idea of how many pi bonds or how many cyclic rings are there in a molecule, okay? For example, understand all this in detail. First of all, after a few minutes, I'll be telling you how to calculate degree of unsaturation, okay? First thing, you should know the significance of this degree of unsaturation. If degree of unsaturation du comes out to be 1, that means there can be either one double bond or one ring in the molecule, okay? If the degree of unsaturation for a molecule comes out to be 1, that simply implies that there can be either one double bond, there can be either one pi bond, which is possible only if there is one double bond, or there can be one ring. Point number 1. Point number 2, if the degree of unsaturation for a molecule comes out to be 2, what all possibilities are there? See, if the degree of unsaturation for a molecule comes out to be 2, the first possibility is there will be two pi bonds. The first possibility is there will be 2 pi bonds. Now, how come there will be 2 pi bonds? Either there will be 2 double bonds at 2 different positions, 2 double bonds, or there can be one triple bond containing 2 pi bonds, right? Or there will be one pi bond, one ring, or there can be simply 2 rings. These are the possibilities which arise when the degree of unsaturation for the molecule for a compound comes out to be 2. Okay, again I'm repeating the same. If the degree of unsaturation for a molecule comes out to be 1, therefore there'll be one pi bond, which is possible only if there is one double bond, right? Or there can be one ring, either one pi bond or one ring, okay? Similarly, if the degree of unsaturation for the molecule comes out to be 2, a lot of possibilities arise. There has to be either 2 pi bonds or 2 rings. 2 pi bonds or 2 rings. 2 pi bonds are possible only if there are 2 double bonds at 2 different positions, or one triple bond, right? Or there can be 2 rings, or there can be one pi bond, that means one double bond and one ring, correct? Okay, remember this. Let me know in the chat box if you got it. Let me know in the chat box if you got it. Then only I'll show you how to calculate du for any molecule. Let me know in the chat box first if you got it or not. Yeah? Right? Right. Okay, now people have a look. Let me talk about the first case. Let me talk about the first case. Let me talk about the first case. Exactly, Karthik. Let me take the first case over here, okay? Let's take the general unsaturated hydrocarbon. Let's take the general unsaturated hydrocarbon, whose formula I'm taking as CXHY, okay? General unsaturated hydrocarbon, CXHY, okay? If I need to calculate degree of unsaturation for this CXHY, I've got one simple formula to calculate it. It is 2x plus 2 minus y divided by 2, where x stands for the number of carbon atoms in this one and y stands for the number of hydrogen atoms in this hydrocarbon over here. Okay, this is the simplest formula to calculate the degree of unsaturation in the hydrocarbons. Okay, in case of hydrocarbons, how do we calculate degree of unsaturation? Simple, 2x plus 2 minus 2x plus 2 minus y divided by 2. X stands for the number of carbon atoms, y stands for the number of hydrogen atoms. Let me take few examples so that you get the clear-cut idea of how to calculate it. Example number 1. Let's say I've got C2H4. Let's say I've got C2H4. If I ask you what is the value of X over here, X means simply the number of carbon atoms, right? The value of X right here is 2. What is the value of Y over here? The value of Y over here is 4, correct? Now I need to calculate du for this C2H4 over here. Du formula is simply going to be equal to 2x plus 2. X value is 2, so 2 2s are 4, 4 plus 2 is 6, right? 6 minus y, 6 minus 4, 6 minus 4 divided by 2. The value comes out to be 1. So du value for this compound is coming out to be 1. So there can be either one pi bond or there can be one ring. Ring is not possible because there are only 2 carbon atoms. So there is one pi bond in this molecule over here. So the possible structure of this C2H4, isn't it going to be like this? Right? Okay. Since the ring is not possible because there are only 2 carbon atoms, correct? Yeah? Right? Let me know in the chat box. Let me know in the chat box. Very simple, right? Similarly, let me take few more examples. I've got benzene, C6H6. People already we know the structure of benzene. Yeah? Already we know the structure of benzene. What is the structure of benzene? It's like this. There is one ring and there will be 3 pi bonds, right? There is one ring and 3 pi bonds. So degree of unsaturation, degree of unsaturation has to come as how much? It has to come as 4. There is one ring and 3 pi bonds. Let's exactly see if the degree of unsaturation is coming out to be 4 or not. Simple. I'll be using the formula. What is the value of X? X means the number of carbon atoms, that's 6, right? What is the value of Y? Y value is again 6. Just put these values into the equation. 2x, that means 2 multiplied by 6, that is 12. 12 plus 2 is 14. 14 minus 6 is 8. 8 divided by 2 is 4, correct? So degree of du is 4. Du is 4. That means there is actually one ring and 3 pi bonds, as simple as that, right? Okay. Right? Right. Let me know fast in the chat box if it is clear. Perfect. Let's move on. Let me take few more cases by means of which everything will be clear to you, right? So degree of unsaturation for benzene is 4. That means there are 3 pi and 1 ring over here, right? Moving on to a few more examples. I've got C4H6. X value is 4, Y value is 6, right? And you know the formula to calculate du or dB. After using that formula, the du value for this one comes out to be 2, okay? Du value for this one comes out to be 2. So what all possibilities are there? Correct? There can be either 2 pi bonds, correct? There can be either 2 pi bonds, right? Let me show it to you over here. These are the possible cases over here. Understand? There can be either 2 pi bonds, or there can be 1 triple bond, or there can be 1 pi bond and 1 ring, or there can be 2 rings. These are the 4 possible cases which arise over here. See guys, very simple. C4H6, right? X value is 4, Y value is 6. Degree of unsaturation comes out to be 2, right? So the first case, there can be either 2 pi bonds, or there can be 2 rings, right? Or there'll be 1 pi bond, 1 ring, right? Okay, now people understand. There can be 2 pi bonds, which is possible if there'll be 2 double bonds, right? 2 pi bonds is the first case, which is possible if there will be 2 pi bonds or 1 triple bond. In the first one, we have got 2 pi bonds. And in the second one, we have got 1 triple bond containing 2 pi bonds. So these two structures, they satisfy the first condition that there are 2 pi bonds, right? So these are the 2 possible structures right here, okay, which contains 2 pi bonds. Now it depends. These 2 pi bonds will be either at two different positions or the two pi bonds will be right here at the same position. Okay. Now what is one more case over here which arises? There can be one pi and one ring. This is one pi bond and one ring. Or there is one more case, two rings, like simply like this. Yeah. Okay. You have to, it's your brain which is going to work right here. You get the value of degree of unsaturation and after that you propose the structures. Yeah. Simple. Degree of unsaturation I got to know as 2. So possible cases are 2 pi bonds, right? 2 pi bonds are possible if there will be 2 double bonds at 2 different positions or 1 triple bond, right? Or there is one more case which arises 1 pi bond and 1 ring, or one more case that is there will be 2 rings, correct? So my 4 possible structures will be like this, yeah? Right? Okay. Sumit, just wait. You'll get the idea of all that in a while. Okay. This is the first case which I'm showing you. Correct? Okay. Now, people, let's talk about few more cases. Case number 2. If any monovalent atom is present, right? If there is any halogen attached. For example, have a look. Understand. See, guys. Let's say I've got the compound like this, C2H5X, and X I'm assuming as the halogen, monovalent atom, okay? X is the halogen. Remember guys, rule number 2, this is case number 2. Whenever you see any monovalent atom present in this molecule, what you are going to do at that time, how you are going to calculate the degree of unsaturation, you are going to remove the X, and after removing the X, you are going to add the same number of hydrogen atoms. Okay, if you are removing 1x, you are going to add 1 hydrogen. If you are removing 2x, you are going to add 2 hydrogens, right? Okay, whatever monovalent atoms you are removing, same number of hydrogen atoms you are going to add. Okay, how come? Let's take the example. You'll get a clear-cut idea. See guys, I've got C2H5X, yeah? I've got C2H5X. I'm assuming this X is the monovalent atom over here. Now, whenever the monovalent atom is present, I'm going to remove that monovalent atom, and instead of that monovalent atom, I'm adding hydrogen. So after adding hydrogen, it becomes C2H6. Now, for C2H6, I can easily calculate the DU. And whatever is going to be the DU for C2H6, same will be the DU for this C2H5X. Remember this, okay? Right? Right? So let me show you exactly. So after removing the monovalent atom, you have added the hydrogen. When you will calculate the DU value comes out to be 0. That means DU value is coming out to be 0. You know the formula to calculate DU, right? If DU value is coming out to be 0, that means there can be neither a pi bond nor can be there a ring. Because you have got only 2 carbon atoms right here. Ring is not possible at all, correct? Okay. And C2H6 structure you only know. A CH3, single bond CH3, right? Perfect. Let me take few more examples. You have got C6H4Cl2. So basically you have got 2 monovalent atoms. Now you are going to remove these 2 monovalent atoms, and instead of these 2 monovalent atoms, you are going to add 2 hydrogens. So finally you get something as C6H6, right? You get something as C6H6 after adding 2 hydrogens, right? And C6H6, its DU value we have calculated few minutes back, it's 4. So DU for this molecule, this compound right here is again going to be 4. Now you can propose your structures, right? You can propose your structures, correct? Yeah? Okay. Moving on, we have got C2Cl2. We have got simple C2Cl2. Similarly, you can do it in the same way, right? Remove these 2 chlorines, add 2 hydrogens. Now for this C2H2, calculate the DU. You know the value of X, you know the value of Y. X stands for the number of carbon atoms, Y stands for the number of hydrogen atoms. Use the formula, get the DU. Once you get the DU, you can easily propose its structures, right? Okay. Yes, Chinmay, you can watch here also, no issues. Right? Right. Now, people, there is the next case. If any divalent atom is present. Right now, the case number 2 was if a monovalent atom is present, remove that monovalent atom. Instead of that, add the hydrogen atom. Now, understand. If any divalent atom is present, simply remove that divalent atom. No need to add any hydrogen atoms, no need to subtract any hydrogen atoms. Remove all this. Remember all this, okay? Whenever any divalent atom is present like oxygen, like sulfur, you're simply going to remove that, okay? Now we will see. C3H6O. Oxygen is the divalent atom, remove it. After removing oxygen, no need to add any hydrogen. Now what I get? I get something as C3H6 after removing oxygen. Now X value you know. X value is 3, Y value is 6. Use the formula. Get the DU value. It comes out to be 1. du value comes out to be 1, right? Now people, understand one important thing. Du value comes out to be 1. What does that mean? What does that mean? Du value comes out to be 1. That means there can be one pi bond or there can be one ring. Correct? There can be one pi bond or there can be one ring. Now people, pi bond is possible right here in this molecule. Pi bond is possible between carbon and oxygen, or pi bond is possible between two carbon atoms, right? Correct? See, I'm telling you, degree of unsaturation for this molecule is 1. So there can be either one pi bond or one ring. If I talk about the pi bond, this pi bond, it can be either between carbon and oxygen or it can be between two carbon atoms, right? Correct? Right. Let's check the possible structures which this C3H6 has. So the possible structures can be like this. These 6 are the possible structures. Now understand. I told you du value is coming out to be 1, correct? Du value is coming out to be 1. That means there can be either one pi or there can be one ring. Now what all possibilities arise over here? Understand. This pi bond, it can be either between carbon and oxygen or it can be between carbon and carbon, right? Let's talk about these possibilities. If you look at the first structure, the double bond is between carbon and oxygen, right? If you talk about the third structure, the double bond is between carbon and oxygen again, right? These are the two possible structures which are satisfying this condition, right? Now, if you look at these two, the double bond is between carbon and carbon, double bond is between carbon and carbon. So these two structures, they are satisfying this condition, yeah? Right? Now, there can be a ring as well. Okay, this is one possible ring, your alcohol. This is one possible ring, your ether. Everywhere you see, molecular formula is going to be same. Yeah? Right? Let me know in the chat box if it's clear to you. People, after getting the du, you can clearly guess the structures of these. Yeah? Let me know in the chat box if it's clear to everyone. Let me know fast so that I can move on. Divya, you just refresh your page once, it'll be clear to you. Okay, because on my side, connectivity is all okay. Yes, I'll be teaching tautomerism as well, but not in the today's session, in the next session. Right? Right. Let me know in the chat box if it's clear. Correct? So we will only think, no need to worry about these structures and all. Only thing, just know how to calculate du. This was the third case, correct? Now people, the fourth case. If any trivalent atom is present, if there will be the trivalent atom, what you'll be doing? You'll be removing the trivalent atom and you'll be subtracting the same number of hydrogen atoms as well, okay? First thing, you'll be removing the trivalent atom, and after removing the trivalent atom, you'll be removing the same number of hydrogen atoms as well, correct? For example, understand. Log derivative. Bro, this is chemistry going on. Anyways, log x, its derivative is 1 by x. Okay. See guys, if any trivalent atom is present, what do we do at that time? We are going to remove all the trivalent atoms, and apart from that, whatever trivalent atoms, the number of trivalent atoms we have removed, same number of hydrogen atoms we are going to remove as well. Okay? Okay. Now people, take a look. We have got the molecule as C6H7N. This N, it's trivalent. Similarly, phosphorus is trivalent, right? Okay. Now what I'll be doing, I'll be removing nitrogen. I'll be removing this trivalent atom. And after removing the nitrogen, I'll be removing one hydrogen as well, right? So it's going to be C6H6. And for C6H6, we already know the du. That's 4. That means for this molecule, du is again going to be 4, right? Du is again going to be 4. Okay. Right? Talking about few more examples, this is something which we have done, du value coming out before. People, one more interesting thing. Remember, whenever degree of unsaturation comes out to be greater or equal to 4, the structure will be having one benzene ring. One benzene ring means one ring and 3 pi bonds. Remember, for any molecule, if the degree of unsaturation comes out to be greater or equal to 4, remember, strike that, remember that there will be one benzene ring necessary in that molecule. For example, see, if I talk about C7H6O, right? If I talk about C7H6O, okay. First of all, we have got oxygen. Oxygen is the divalent. Just a second, guys. Just a second. Just a second. Just a second. Okay, talking about this C7H6O, okay? First thing understand, we have got oxygen as the divalent atom. If there is the oxygen, if there is any divalent atom, we are simply going to remove that divalent atom, okay? After removing, what do I get? I get C7H6, right? I get C7H6. I'll be calculating the degree of unsaturation for this C7H6, which comes out to be 5. Degree of unsaturation for this compound is coming out to be 5. That means what I'm going to do, I told you a few minutes back, I told you, whenever degree of unsaturation comes out to be greater or equal to 4, the structure is definitely going to contain one benzene ring, okay? So people understand, degree of unsaturation right here came out to be 5. So there'll be first of all a benzene ring. So there is first of all a benzene ring. So in this benzene ring, what all things we have? We have got 3 pi and 1 ring, okay? We have got 3 pi and 1 ring. So since it has 5 degree of unsaturation and I have used only 3 plus 1, 4 till now. So 1 is pending, okay? So where do I fit that one? It's going to be C and it's going to be double bond O. This is going to be simply H. Now understand, there are 1, 2, 3, 4. 4 pi bonds, 4 pi bonds and 1 ring. So 4 pi bonds and 1 ring means degree of unsaturation is 5 for this one. Yeah, I'm sure this again clear to you. Taking few more examples. Important one. Degree of unsaturation is always equal to number of pi bonds plus number of rings. Degree of unsaturation is equal to what? Number of pi bonds plus number of rings, okay? People, have a look. Do you remember I have given you this molecule in GOC when I talked about resonance conjugation? Do you remember this one? Do you remember this one? Do you remember this one? Can you let me know, is it conjugated one? Is it conjugated one? Do you remember this? Do you remember this? Will it show conjugation? Is there conjugation? Will it show resonance, you tell me? Yeah? Do I have to count this double bond? If you remember in GOC, I've told you in detail, we are not going to consider this double bond, right? It alters the induced current, right? It alters the induced circumferential current. If you remember, I have told you all this in detail in your resonance. Well, I'm not going to talk about that over here. I just need to calculate the degree of unsaturation for this molecule, yeah? Okay, and I told you degree of unsaturation, it's equal to number of pi bonds plus number of rings. So first of all, how many rings do we have? 1, 2, 3, 4. So number of rings are 4. So how many pi bonds do we have? 1, 2, 3, 4, 5, 6, 7, 8, right? 9, 10, there'll be one more, 11, 12, 13. So number of pi bonds are 13. So 13 plus 4 comes out to be 17. So 17 is basically the degree of unsaturation for this compound. Yeah? Simple. Right? Right. Exactly, Aisha. Cyclic resonance breaks. Yes, I remember. Yes, Chinmay, I'll be teaching these topics in Enthuse channel as well, in JE channel as well. Yes. That too, a bit more in detail. This is the NEET channel, okay? That's why I have to go a bit superficially. Whatever is required in NEET, I'm just talking about that stuff. Okay, in JE channel, I'll be teaching all this in detail. Yes, Sumit, everything will be done. Right? Okay, so, and this is people, just a second. Degree of unsaturation comes out to be 17. This is something which is your homework, and you guys are going to let me know the DU value of this in the comment box, okay? Do not forget to let me know the DU value for this molecule over here. It looks complex, it's not, but yeah? Okay? Right? Okay, it looks complex, but it's not. Simple, you're going to count what? You are going to count the rings, and after counting the rings, you are simply going to count the pi bonds. Rings plus pi bonds is going to give you the DU value for this molecule over here, right? I'm sure it's clear to everyone. So people, with this, I'll take a leave. So your DU is clear, I assume, right? Do let me know the answer of this question in the comment box, yeah? And for the ones who are new to the channel, who have no idea about the NEET 2021 crash course, well, people, Bimal, the name of JE channel is Vedantu JE English, okay? I take sessions on that channel at 10:30 in the night, right? So for the ones who are new to the channel, let me give the quick introduction about the NEET 2021 crash course. Well, people, if you want to get trained by the teachers of Vedantu personally in any language, be it Hindi, be it English, you need to go for it, right? And this is the best thing which you can have right now at this moment, okay? First thing, what all benefits you guys will be having in this? We are going to cover your whole syllabus through the actual Vedantu platform apart from the YouTube sessions, number one. Number two, there will be regular assignments, test series, no need to worry about the mock test, everything is included, right? You're going to get the handwritten notes. You're going to have the sessions with the experts who are going to let you know how to solve the questions in lesser time, okay? Right? There will be tips and tricks by means of which you can solve the questions in lesser time, right? Okay, you'll get the idea about the time management, right? And at the same time, it's going to be absolutely a two-way learning interactive platform wherein you can ask your doubts anytime to your master teacher. So do get enrolled in this one. It's going to be definitely beneficial for you. Trust me on that, okay? Do get enrolled in this one. At the same time, how to get enrolled? You just need to download the Vedantu app. After downloading the Vedantu app, do one thing. Click on this Vedantu app. After clicking on the Vedantu app, click on NEET Crash Course. After clicking on NEET Crash Course, what you need to do is you need to use this coupon code. This is my personal coupon code, WSNET, Wassim Sir NEET. After using this coupon code, you are going to get 30% off, and I'll be training you over here in this actual Vedantu platform for the crash course ones, for the ones who are going to write the NEET in 2021, I'm asking, yeah? Okay. And the batch starts, the next batch is starting on 24th, okay? Right? The next batch is starting, on 17th of May, okay? Do get enrolled in this one, right? I guess today is 15th, is that? 15th or 14th? What is the date today, by the way? It's 15th. So on Monday, the next batch of crash course is going to get started. People, do get enrolled in this one, trust me, okay? This is my personal suggestion. If you want to improve your rank, this is the best thing which you can have right now, okay? Okay, and at the same time, I've seen people getting enrolled in the crash course, shooting up their performance, shooting up their ranks, shooting up their marks by 50 to 60, trust me on that. And we are going to cover your whole syllabus before your NEET 2020 examination in 120 sessions, and at the same time you are going to get trained personally by us in all the three subjects, physics, chemistry as well as biology, right? Link is there in the description box. You click on the link, okay, and do use the coupon code as WSNET, right? Suryansh, I've already done chemical bonding, you can watch that. Well, most probably next week I'll be starting the coordination chemistry at the same time, right? So for the ones who are going to write the NEET in 2022, the batch is starting again on 17th of May, right? The batch on the actual Vedantu platform is starting on 17th of May. Link is there in the description box. Click on that link, right? And people, you can get enrolled in this batch by means of this EMI facility is also there, right? Okay, and in order to get enrolled in this batch, use the coupon code WSPRO to get the additional discount, right? And there is one more link in the description that is for the Telegram. Do click on the link, get added to the Telegram group and stay updated about the classes. And for the ones who have not liked the video yet, please do like the video, share the video with your friends and subscribe to the channel, and do not forget to hit the bell icon so that you get the notification of every single session which I'll be taking over here on this channel. Yes, Ayush, definitely do that. For if you have any more queries regarding the crash course, regarding anything, you can ping me on my Instagram. Its ID is, I guess I don't remember it. First, it's WASSIMBHAT. You can search it, okay? You can let me know your queries on my Instagram, right? Okay, do get enrolled in the crash course as soon as possible. The next batch is starting from Monday. If you want to shoot up your performance, this is definitely going to be helpful for you. Trust me on that, okay? Surely, Aryan, why not? Chinmay, my next class on Enthuse is tonight at 10:30 p.m. Yes, tomorrow I'll be coming on Vedantu Biotonic as well. Your Vani Mams, your favorite Vani Mams channel, okay? And tomorrow at 5 p.m. you will catch me there on We Biotonic, yeah? Till then, you guys take care. Bye-bye. God bless you all. Love you all and keep safe, right? Bye, guys. Take care.